Welcome viewers, in this video we will see the solved problem in superposition theorem using the DC source. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The statement of the problem is find the current in 2 ohm resistor between A and B for the network using the superposition theorem. We need to find the current flowing through 2 ohm resistor. It is marked as AB. Now refer the diagram. So the network is available. We need to find this current flowing through this 2 ohm resistor. This termed as IL, right? This marked as AB. So the other 1, 2, 3, 4 resistors are available apart from the load resistor. 5 ohm, this 3 ohm, 4 ohm and 2 ohm. We have two voltage sources are available. 10 voltage source and 20 voltage source. So according to superposition theorem, what is the statement? So we need to consider only 10 voltage source alone. By removing 20 voltage source, we need to find what is the current flowing through 2 ohm resistor. In the second step, we need to remove this 10 voltage source, only need to consider 20 voltage source. For that, we need to find what is the current flowing through this 2 ohm resistor. So the total current is nothing but the current due to 10 voltage source and current due to 20 voltage source. We need to add both the currents. That is the statement of the superposition theorem. Now we'll go to the step 1. So the step 1 is nothing but considering 10 voltage source, remove 20 voltage source and 10 voltage source only is acting. Right? We need to consider only 10 voltage source. 20 voltage source is removed. What is meant by removal of 20 voltage source is short circuited. We need to short circuit the voltage source 20 voltage. Then we need to find current. Now we'll go to the diagram. After removal of this 20 voltage, the circuit is reduced, so that we'll see that what is the reduced circuit. So this here the 20 voltage source is removed and make it as short circuit. Now we have only the 10 voltage source is available. Now our aim is to find what is the current flowing through this 2 ohm resistor due to only 10 voltage source. Right. So this circuit is further simplified that these 2 ohm and 4 ohm, these two are connected in parallel. This 4 ohm and 2 ohm are in parallel. Right. So we can find this equivalent resistor. So that R equivalent is 4 into 2 divided by 4 plus 2. That is R1 into R2 divided by R1 plus R2. That is the equation for finding the equivalent resistance when two resistors are connected in parallel. So 8 divided by 6, it is 1.33 ohm. Right? These 2 ohm and 4 ohm are connected in parallel. So that equivalent resistor is 1.33 ohm. So that is available here. So these resistors are connected. These two are in parallel. After simplification, the equivalent resistance is 1.33 ohm. Now the circuit is further simplified. Right. So our aim is to find this current through 2 ohm resistor. So we can use the loop method. Kirchhoff's voltage law, KVL using loop method. Right. So this is the first loop. The current is I1. This is the second loop, I2. Loop means closed circuit. This is the first loop. Loop 1. The current flowing through the loop 1 is I1. This is loop 2, second loop. The current flowing through the loop is I2. So what is the current flowing through this 2 ohm resistor? I1 is flowing from top to bottom. I2 is flowing from bottom to top. So the difference, both are in opposite direction. So I1 minus I2 is the current flowing through 2 ohm resistor. So we need to find I1 value and I2 value. The difference between I1 and I2 is current flowing through 2 ohm resistor. See this, I1 is flowing downwards. I2 is flowing upwards. So the difference between these two is flowing through 2 ohm resistor. Now we'll go to the matrix method. We will go to the matrix method. So this is nothing but R into I equal to V. V equal to I into R. This is voltage matrix, current matrix, resistance matrix. Right. First we'll see the resistance matrix. Right. What is that available here? What is this value? This R11. R11 means the total resistor available in the loop 1. That is 5 plus 2, 7. Right. This is R12. R12 means the resistor available between loop 1 and loop 2, commonly available. So this 2 ohm is commonly available between loop 1 and loop 2. So it's minus 2. So other than diagonal, other elements are negative. So it is minus 2. This is R21, same thing. The common resistor between second loop and first loop, that also 2 ohm resistor. So minus 2. Then R22. What is R22? The total resistor available in the second loop, that is 3 plus 1.33 plus 2, right? 3 plus 1.33, 4.33 plus 2, 6.33, right? So this is the resistance matrix is formed. This R is nothing but total resistor available in the loop 1. 6.33 is total resistor available in the loop 2. These two is commonly available between loop 1 and loop 2. Then currents are I1 and I2. Here I1, I2. What is the voltage available in loop 1? 10 voltage. In loop 2 there is no voltage source. It is 0. Right? So this Kirchhoff voltage law, KVL method, loop method available, separate videos are available. Right? So here they are directly given. So we can take, this is the delta, del value, that is 7 minus 2 minus 2, 6.33. We need to find the del value. We need to simplify this. We have to find the determinant of this matrix. So 7 into 6.33 minus 2 into minus 2. There are already one minus is available here. This is also minus 2. This is also minus 2. Right? So 7 into 6.33 is 44.31 minus. So 3 minus available. So finally it is minus only. 2 into 2, 4. So after subtraction, what we got? 40.31. The delta value is 40.31. Now we need to find the delta 1, delta 2 followed by I1 and I2. What is delta 1? Delta 1 is nothing but you have to replace the first column with the voltage matrix. That is delta 1. Replacing the second column with the voltage matrix is the delta 2. Right? The delta is as it is. We have to write. Delta 1 means first column is replaced by voltage matrix 10 0. Second column is replaced mean delta 2. Right. So the delta 1 after replacing what we have, it is 10 minus 2 0 6.33. So one is minus 0 is there, only we need to multiply these two. 10 into 6.33 minus 2 into 0. So this term becomes 0. So 10 into 6.33 is 63.3. Del 1 value is 63.3. Then we have to find the delta 2. Delta 2 is 7, 10 minus 2, 0. So 7 into 0 is 0 minus of 10 into minus 2. Already here minus 1 is there, here also minus there. So 2 into 10, 20. Right? Now we calculated the delta 2 value also. Del value available, delta 1 available, delta 2 also available. Now we'll go to the current. From that we can find the current value. So I1 is nothing but delta 1 divided by delta. 63.33 divided by 40.31. Just now what we calculated. These two values are calculated. So that it is 1.57 ampere. By dividing this we got 1.57 ampere. Similarly I2 is delta 2 divided by 2. So 20 divided by 40.3, that is 0.496 ampere. Now we calculated I1 and I2. We already discussed current flowing through the 2 ohm resistor due to 10 voltage source alone is nothing but, that is we taken as I dash, right? The 20 voltage source is I double dash. So that is the difference between these two current, because both the currents are flowing in opposite direction. I1 minus I2. I1 value is 1.57. I2 value is 0.496. So the difference is 1.076 ampere. So this is the current flowing through the 2 ohm resistor due to only 10 voltage source. Only the 10 voltage source. Right. So the step 1 is completed. We consider only 10 voltage source. We calculated what is the current flowing through the 2 ohm resistor due to only 10 voltage source. Now we'll go to the second step. Considering 20 voltage source, removing 10 voltage source. What is the removal of 10 voltage source? Is nothing but short circuit. Right? Now we need to consider only 20 voltage source. 10 voltage source is removed and short circuited. Now we'll see the diagram. After this, what is the equivalent diagram? We'll see that. So after removal of this 10 voltage source, this is short circuited. Only 20 voltage source is available, right? The further simplification, same thing what we did in the step 1. This 4 ohm and 2 ohm are in parallel. So that is simplified. That the equivalent value is 1.33 ohm, right? So these two the resistor now become 1.33 ohm, right? Same thing we can apply the Kirchhoff's voltage law. This is the loop 1. The current is I1. This is loop 2. Loop means closed circuit. The current is I2. The current direction what we is taken as same direction. We are not taken in the opposite direction. We can take in the opposite direction also, because source is available here. Normally the current will flow in this direction, but we taken the current in the same direction. That is our wish. If you take the current direction wrongly, you will get the negative current, negative value. So that is not a problem. We can take either any direction. So the current is taken as clockwise direction only, right? So see, this I1 current is flowing from top to bottom. I2 current is flowing from bottom to top. Same thing. So the difference between these two current is flowing through 2 ohm resistor. What we discuss in the step 1, same thing only. So now we need to form the matrix, right? So this resistance matrix, current matrix and voltage matrix, right? So that the resistance matrix is that. What is that? R7, this is R11. The resistance available in the loop 1, 5 plus 2, 7. What is this 6.33? Resistor available in the second loop, 3 plus 1.33 plus 2. So 2 plus 3, 5, 5 plus 1.33, 6.33. This is nothing but R12 and R21. They are the resistor commonly available between loop 1 and loop 2. This is 2 ohm is commonly available. So minus 2, minus 2. The current is I1, I2. The loop 1, there is no voltage source, 0. Here the loop 2, 20 voltage is available, minus 20. Why it is minus 20? See the current direction. Current is going from top to bottom. That is plus to minus, right? Positive potential to negative potential. So that it is minus 20. If it is from negative to positive potential, previous case it is negative to positive potential. So that plus 10 voltage. Here going from plus to minus, right? See the direction, it is downwards. So current is flowing from positive potential to negative potential. It is a drop in potential. So that minus 20, right? So this is nothing but our del value, right? So the del value, first we will find the del value. 7 minus 2 minus 2, 6.33. So this is very similar to the previous case. 7 into 6.33 minus of minus 2 into minus 2. So this value is 44.31 minus 4, it is 40.31. Very similar value in the previous step 1 also. Del value is 40.31. Now we need to find the del 1 and del 2. What is del 1? Replacing the first column with the voltage matrix is del 1. Replacing the second column with voltage matrix means del 2, right? So the del 1 and del 2 replacing the, here first column is replaced by voltage matrix. Second column is replaced by voltage matrix, that is del 2, right? So 0 minus 2 minus 20, 6.33. So 0 into 6.33 minus of minus 2 into minus 20. Right? So this term is 0. So 3 negatives available. So finally negative only 40, minus 40. Del 1 value is minus 40. Del 2, 7, 0, minus 2, minus 20. 7 into minus 20, minus of 0 into minus 2. Right? This value is 0. So 7 into minus 20 minus 140. Del 2 value is minus 140. See this? In both the case we got the negative value. That means the current what we taken as wrong. It is opposite direction. But it's not a problem. By seeing this negative value we can able to understand the current is flowing in opposite direction what we marked in the circuit. So from this value we can find the now I1 and I2 value. Current I1 and I2. So I1 is nothing but del 1 divided by del. I1 is the del 1 divided by del. Minus 40 divided by 40.31. minus 0.992 ampere. Right. Similarly, I2, del 2 divided by del, minus 140 divided by 40.31. So minus 3.47 ampere. Right. Now we calculated I1 and I2. What is the current flowing through 2 ohm resistor? We already discussed. There are two currents are flowing. I1 is flowing downwards. I2 is flowing upwards. So the current is the difference between I1 and I2. So due to 20 voltage source, it is we are taken as I double dash. I dash means current flowing through 2 ohm resistor due to 10 voltage source. I double dash means due to 20 voltage source. Right. So we need to find the difference. Already minus is there. Minus 0.992 minus of minus 3.47. So the final value is 2.47. So the current flowing through 2 ohm resistor due to only 20 voltage source is 2.47 ampere. Now we calculated two currents, I dash and I double dash, due to 10 voltage source and 20 voltage source. So by the superposition theorem, the total current flowing through 2 ohm resistor is IL dash plus IL double dash. What we calculated, we need to add both the values. So IL dash is 1.076, IL double dash is 2.478. So by adding this, we got 3.55 ampere. Right. So the total current flowing through the 2 ohm resistor due to 10 voltage source as well as 20 voltage source is 3.55 ampere. So by superposition theorem, we are easily calculating, by considering only one voltage source, we are calculating the current. Then considering the another voltage source, calculating the current by the simplified manner. Thereafter, we are adding both the currents. That is a statement given by superposition theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.